Cuando lancé la pelota de fútbol, intervienen fuerzas como la gravedad, la velocidad y la aceleración. Cuando le lancé la pelota a Siberio, tuve que mover mi brazo en su dirección con una fuerza específica para asegurarme de que no fuera demasiado lejos ni golpeara en absoluto. Cuando le arrojaron la pelota a Siberio, la gravedad tiró la pelota hacia abajo, haciendo que la aterrizara cerca de él. La fuerza neta es la magnitud neta y la dirección de todos los vectores de fuerza sumadas. Primero la pelota se dispara hacia Siberio tan pronto como la pelota dejó mi mano. La gravedad tiró la pelota y la obligó a bajar. En el momento en que Siberio atrapa la pelota, la detiene haciendo que la fuerza de detención se desplace hacia la izquierda. La velocidad horizontal no cambia, pero la velocidad vertical sí. Lo sabemos porque en el video se ven que las flechas que suben y bajan. La posición vertical es subir y luego volver a bajar. La posición horizontal va a la derecha, caballo de fuerza. ¿Qué?
When throwing a football, forces such as gravity, velocity, and acceleration are involved. When I threw the ball to Joel, I had motion to my arm towards his direction with a specific force, making sure it wouldn't go too far or not to reach him at all. As the ball was thrown at Joel, the gravity pulled the ball down, making it fall near him. Net force is the net magnitude and direction of all force vectors added. First, the ball is shot up towards Joel. As soon as the ball left my hand, the ball was pulled by gravity, forcing it to go down. The moment Joel catches the ball, he stops it, therefore making the stop force go left. The red arrows split in two different directions the moment it leaves my hand, showing us how the force builds up in the beginning but begins to decline right after. Horizontal velocity does not change, but vertical does. We know this because in the video you see the arrows going up and down. The vertical position is going up and then back down. The horizontal position is going towards the right.
The net force is the air changing towards the ball when it's being thrown. The net force influences the ball to lose force and acceleration because it's the air force that's pressuring the ball to slow down. It also has to be something about the aerodynamics that causes the ball to lose force from the air, so the more sharp form this has, the less air it has pushing it back. The gravity pulls the ball down after the ball is being thrown. The velocity of x would be negative 3.13 and the y-axis would be 0.45. The position of the ball being thrown would be kinda straight but slightly going up.
A general description of the activity provided, one paragraph plus why you enjoy this activity.
We enjoy trying to deploy it with the yo-yo, and with that we also want to show how much strength and speed are perfect example in speed measurement. The project with existing science, we can see other people project as well, and the measurements this will also the part of the final for this class. This will be a urgent relief for me and my home group.
What are the forces involved with the activity? What is the net force?
Gravity and force. The direction the yo-yo is going is down with the net force ways up once we use the force in your hand to bring back the yo-yo to your hands.
How does this net force influence?
When you release a yo-yo, a gravity acts on its center of mass to pull the yo-yo down low. The yo-yo is forced to reload as it drops. If the yo-yo could not reload, it would not drop.
Horizontal x-axis and vertical y-axis acceleration.
X-axis, the arrow never go horizontal in the video. Clip only goes downward and upward or slant. Y-axis, the arrow do you sort of square Since the yo-yo is spinning when in the bottom, but then when pulling back up, of the acceleration goes up with it. Y-axis for the I-axis, the acceleration goes pull down, and when pulling back up, the acceleration goes pull up. The horizontal x-axis start off small in the length, and we will go down the length get much longer, and when pulling back up the yo-yo, the acceleration goes negative, or the arrow to go to a positive direction and get longer, the yo-yo goes up.
Horizontal and vertical velocity.
X. The horizontal x-axis stays the same length through the entire video clip. In the Y, the y-axis starts off with the long arrow, but shortening once they reach the bottom point of the string.
Basically, in our video, me and Jonathan tossed the ball in the air, and as the ball came down, they were about to land at the same time, but one of the balls hit my shoe, causing it to roll off. You can see in the video how the velocity changes, and it starts to roll away. Also with that, obviously the position changes all the way through. We threw the ball at different timings, but they still almost managed to hit the ground at the same time. And also in the beginning of the video, as the balls are thrown in the air, acceleration, obviously there's acceleration, the ball goes up, but then it also starts to accelerate downwards. And then as soon as it hits my shoe, it also accelerates even more. Jonathan's ball also bounced in the air several times. You can just see how the acceleration changes a lot. And it goes up, down, up and down.
The forces are weight, drag, and lift. The net force is gravity plus the applied force. The initial applied force is bigger because we use that to throw the ball. Once the ball leaves your hand and it's moving upwards, it has velocity. The ball is moving pretty fast, and as it's going down, the ball decreases its speed. It has vertical acceleration and vertical velocity.
The acceleration of both vertical and horizontal are pretty consistent throughout the video because the red arrows that we see in it are about the same length, and the net force affects because it is pushing against the ball. The vertical velocity is affected by the net force because, as we can see in the video, the arrow pointing up is decreasing by a lot until we see it have no more velocity due to its reaching its highest point and then falling. But the horizontal velocity is decreasing steadily but surely, as we can see the arrow getting smaller. It influences the position because when the vertical velocity starts decreasing, it stops it from going any higher than its highest point, therefore then stopping for a brief moment, and then the gravitational force makes it fall down. The net force affects the horizontal because of the acceleration pushing against the ball, therefore causing it to lose speed and slow down.
What are the forces involved with this activity? What is the net force? The forces involved with this activity are friction force and impact force. The net force is the impact force when Sonia hits the ball, and gravity because after the impact force, the ball is slowly falling. How does this net force influence? The net force does not affect vertical acceleration because there are no vertical forces acting upon it. The net force affects the horizontal acceleration because the ball is getting hit horizontally, therefore there is a horizontal force acting upon it. The net force influences horizontal velocity because Sonia is hitting the ball quickly in a horizontal direction. The net force influences the horizontal position because the position of the dots are going up and gravity pulls it down.